if you have A times B equals 0 mathematically, if A and B are different and they multiply to 0, the natural conclusion is that A equals 0 or B equals 0. That's the conclusion that you would draw. So, or come to. Over here, this thing here, the first bracket, is like A. So you could say, for example, whoops, you could say x plus 2 equals 0. What the heck happened there? X plus 2 equals 0, or x plus 3 equals 0. And that's how you get the two answers, because then what you do is you move the 2 over to get -2, or you move the 3 over to get -3. So that's why they're the opposite signs. This is a very common pattern that obviously falls through the cracks. It's not loading. I'm not sure there. Is anybody else getting it? Okay. Okay, Ethan. Don't worry about it. I'll check it out after, but you can just follow the questions here for now, if that's okay. We'll have to do it this way now. And if you still can't open the document, I'll just email me and I'll reply to you with the document. Hopefully it doesn't happen again. Okay, so that's the you're welcome. That's the process there. So what I want to do now is just repeat this process maybe 2 more times. So over here and over here. So in this next one, we want two numbers that multiply to 7. Adnan, what happened there? You wrote down the whole thing. Okay, multiply to 12 and add to 7. So what numbers do that? What? 4 and 3. Okay, 4 and 3 it is. So you get x plus 4 and x plus 3. So you get -4 and -3. And you can play this game all day here. The numbers get bigger, but the process is the same. So we can multiply to 21. Thank you, Adnan. 10 and 11. Whoops, I wrote 21 and 110. Okay, and you can play this game all the way here with negative signs. It's the same thing over and over again. I'm going to move it over here. Take a look at example 6. So all of these questions are the same. It's just that the numbers get progressively harder. Notice that every single question up to 6, there's a 1 in front of the x squared. But and this one here just has big numbers. I'm going to leave that one for you to try as a challenge. And if anybody's curious, maybe I'll take it up during the break. I'll show you how I would do that. So 6 has got some big numbers. And anyway, I could show you a way to do this that would take you less than 2 minutes by hand without a calculator. So if you're curious, the only difference is if you don't have a calculator, you got to type a lot of stuff. Okay, so let's do question 7 because 7 has a twist to it. In question 7, we want to multiply to 42 and add to 17. So why do you want to multiply to 42? What's the difference here? if we look in the front here, there's a 2 now. So you do 2 times 21. That's how you get 42. 2 times 21, okay? But the process now, you can't just jump to the answer. So for this one, I'm going to remind you about something called the decomposition method. Yeah, I'm going to get to that in a second. Decomposition. And the decomposition method, I'm going to actually get the things in a second, Jaden. The decomposition method, I'm going to just write this down for a second, copy the question, and I'll explain to you why. So what are the numbers that multiply to 42 and add to 17? 14 and 3. So in the decomposition method, what you do is you put 14x and 3x in the middle. So what you're doing is you're taking the 17x and you're decomposing it or breaking it down into those two. And then what you can do is grouping. So you take the first two terms and you can take out an x and a 2. And from the second two terms, you can take out an x and, sorry, a 3, and you're left with x plus 7. So that ends up being the factored form. And then if you recall, we talked about A and B. So you take this idea here, and you apply it to the question. So you take this thing here, 2x plus 3, and you set it to 0, or you set x plus 7 to 0. The latter of the two is easy. So this one's -7. That's easy. But this is the one that people often will confuse themselves with, and it's just pretend the 2 wasn't there. If the 2 wasn't there, it would be -3, and then you divide by 7. So those are the two answers to the factoring. Nice job, Adnan. How long did it take you, my friend? In all honesty, 1 minute. Not bad. Okay, sorry. It's okay. Y7, Mason, where are we talking about the 7? Here? Are you talking about this 7 here? Y divide by 7. Oh, shoot, that's a typo. My bad. That's a typo. Yeah, Graham, I go over all of this in the factoring videos. Do those 3 videos. Trust me. They will make your life a lot more manageable with this factoring stuff. And in terms of how it might affect your midterm, you can still solve questions without knowing how to factor. You just have to use that nasty formula that we're about to review. So the formula is all good, the quadratic formula, but it's slow. And factoring is fast. So this is about me saving time, not not about you can't answer the question too bad. It's about time. That's all we're arguing about right now. We're not arguing, we're debating. Can you went from line 1 to line 2? From this line here, sorry, from this line here to this line here? The grouping. So from this line here to this line here. Correct? The next two. Okay, so I'm going to give you a little abstract question on the side, Graham. So the question for the rest of the class is the question is this. What the heck happened there? How would you factor that one? What do those two things have in common, Graham? They have the heart in common, don't they? Yes. Well, guess what? In this case, the 2x plus 7, think of it like the heart. Nice, Khalid. So you got that? You can take the heart out. That sounds very like evil. Like that. So that's what I did here. That's exactly what I did here. Let me put the x plus 7 first to just make it look identical now. You see that now? Just pretend the x plus 7 is a picture, just like the heart is. And then you take it out. You can make it in. If you made x plus 7 invisible, I think that you would see that the leftovers are 2x plus 3. Okay, we're going to move on now. We're going to move on now and talk about some algebra. So yeah, for those that need some help on factoring, you know what you got to do. Watch those 2 videos and maybe the third one. 40 minutes of your life, you'll never be more appreciative of factoring. So question number 10, let's take a look at it. Don't worry, your midterm's not going to be a factoring test. I haven't written your midterm yet, but it's not going to be a factoring test. I'll give you details about the midterm probably through Blackboard on Monday, because I haven't created the midterm yet. I want to see how you guys do with the quiz today, because the quiz today is a little bit hard, and I want to see what the reaction is in terms of your performance. It'll help me design the midterm better. So that I'm trying to it's a stress test, if you know what I mean. Anyway, in this question here, the first step, although it's cubic, if you expand it out, notice that the cubic terms disappear because they both appear on each side. So we end up with negative 4v equals negative v squared. And now it's a matter of just doing some housekeeping. The mistake that people make here, it's not a mistake, but it's sloppy. Don't do this. Don't cross out the v's like that, the v and the v squared. That's a bad idea because you're throwing away one of the solutions. You should always try to factor when you have expressions. So if you're like, how do I solve such questions? Your goal should always be to make it equal to 0. You want to make it equal to 0. That's really important. If it's not equal to 0, then it's hard to do stuff later. So in this case, we can take out a common factor, which is v. And then you get the 2 answers, v equals 0 or 4. So you might be wondering, you probably understand where the 4 came from, but you might not understand about the 0. Remember that when you have a question like this, using the analogy of A and B that I mentioned earlier, that template, you would say either v equals 0 or v minus 4 equals 0. So you can see it. The first one is literally in your face. It's right there. It's done. So hopefully it makes it a little bit more manageable. I think we're doing okay on the pace that I was hoping to set. And there is really one more, not serious, but one more critical, I should say. Serious, critical, what's worse? I don't know. One more important algebraic technique that we should cover, and that's question 11. So this is something that you would have seen most likely in if you've taken advanced functions. If you haven't taken advanced functions or equivalent, then this is a question that you should follow along very closely. It's not a hard question. It's just that you haven't seen it before. So I'm going to talk to you about it because it's important in handling many of the application questions in this chapter. How the heck does this question here relate to ax squared plus bx plus c? How does this thing here, how is it related to this? Oops, I need my equation on. Somehow these things are connected to each other. So we're going to figure that out. Yes, this is a rational function, absolutely, Jaden. So the way that this relates is because you can turn it into such a question. So if we have 1 over x minus 3, let me just copy this down. The first thing that you can do here is you can actually what's called, you can clear the fraction. And what I mean is that you can get rid of the fraction altogether. So if you take this fraction here, clear the fractions, I should say, you can multiply everybody by a polynomial of some sort that would remove all the fractions. So follow this, for example. What happens if I multiply everybody by x? Let's multiply everybody by x. Because remember, with equations, as long as you do it to one side and you do it to the other side the same way, then it's okay. Golden rule of algebra. So if I do that, can anybody comment on how that affects the fractions? Do we get rid of any fractions now by doing this? Do any fractions go away now? Yeah, you lose one. Thank you, guys. So that's good, but we can do better. So what we're going to do is we're going to multiply by x minus 3 as well. If you're getting scared of what I'm doing, I promise you that this pattern does not get harder. It's going to be very predictable compared to this. And if for those that have taken advanced functions, I think they'll agree with me on this very, very because it's a very predictable approach. Now notice here the x minus 3's cancel, and here the x's cancel. So when you look at it from the big picture, there's no more fractions. So this first term, the only thing that survived was an x. From the middle term, we have a 4 bracket x minus 3. And from the final term, we have 2x x minus 3. I didn't do anything dangerous here. I just put the coefficients in front. So this 4 here, I put it in the front of the term. And this 2 here, I put it in the front of the term. And look at that. If I expand this thing here, and I make it equal to 0, then I get the form that's in the top right here, which is the standard form for quadratics. So let's expand that out and get to something meaningful that we can solve. You don't have to do it as fast as me. I'm just trying to encourage you to like not get too scared of that. But the thing is that I don't want to review stuff that I think that you can be good at with independent study. I just moved everybody to one side so that it equals 0. Hopefully I did it right. You guys are going to check my algebra with me here. What is that? Minus 2x. I got to cheat. Minus 11x. Oh, yes, minus 4. Better? No, you had it right, Graham. That's my bad. One thing I don't like doing during my lessons, with you guys especially, is I don't like looking at my answer, because that's like, yeah. I don't like to cheat, because then you think, oh, this guy's doing it so easy. I want you to see me make mistakes and call me out on it, because then I know that you're in the game, and also that I need to be more careful and slow down. Anyway, this question here is just another basic factoring question, except that there's a 2 in front, meaning that it's the harder decomposition method. Since a is not equal to 1. So that's the reason I use decomposition. I know there are students in this audience that for sure know other ways of doing it. And to be honest with you, the way that I'm presenting decomposition is not the way that I did it in high school either. I had my own shortcuts. But I'm not going to show you the factoring for this one. I'm just going to go for the answer here, if you don't mind. So Anyway, that right there, that jump there is like literally a 2 or 3 minute conversation. But I promise you, watch those videos. Watch those videos, guys. You're going to be just fine with this factoring. So 2x minus, and for those that do watch the video or videos, please drop me an email and tell me what you thought. Not about the video. I don't care about the feedback for me. I want you to tell me that it helped, because if it didn't help, I'll do more. I'm confident that it will, but I just don't want to speculate. Anyway, those are the answers. It's important to check the restrictions here. Notice that you can't have a zero denominator, so x should not be 3 or 0, because if x was 3 or if x was 0, the denominator would be 0, and you can't divide by 0. You cannot divide by 0. So these numbers here, these solutions for x, are definitely okay because they do not violate the restrictions. So that's enough of that. Let's do an application question, and let's practice the quadratic formula, and that should take us into a good place for a break. Maybe we'll do the quadratic formula twice before the break, and then after the break, I'm going to show you how to just get the key features of a graph and do some word problems. So let's see how that goes here. Question number 12, just one application question. So it says here, just read question 12 while I create the structure of the solution here. I think the answer is 10 out of 9. Good work. Now let's talk about this here. What is the old area? What's the old area? 60, 600, 20. So the old area is 600 centimeters. What's the new area? 1200 centimeters squared. All right. So we know that the old area and the new area are 2-to-1 ratio. It says here by adding the same amount to each dimension. So what are the new dimensions? You can definitely guess the answer like that or write it down like that. I wanted to do a statement here. Let x be the amount So what are the, thank you, Graham. That's what I was looking for, just the intermediate thing here. So the new dimensions would be 20 plus x and 30 plus x, and those are in centimeters. So we now know that the new area is, oops, having a little technical issue here. So there's your formula that you want to solve. The new length and width are 20 plus x and 30 plus x. You multiply them to get 1200. You want to solve this equation. So the goal is to make it equal to 0. You're trying to make it equal to 0. So what I would do is I would expand this out by using the distributive property, or FOIL. So 20 times 30, 20 times x, 30 times x times x. I'd also move the 1200 over, and that equals 0 now. So I expanded it all out, and I made it equal to 0. So now we're in a good place, because you have a quadratic equation. You have x squared plus 50x minus 50x minus 600 equals 0. What's the factored form here? So you're probably wondering, two numbers that multiply, negative 600, add to 50. What numbers multiply to negative 600 and add to 50? Anybody have another? So it's negative. Yazan, they're negative. Thank you, Stephen. That's a good one there. X plus 60, x minus 10. Then you get x equals negative 60, or x equals 10. The answer has to be 10, because you can't put, if you put negative 60 here, you're going to get a negative length or width. So the answer has to be 10. So this is your answer. So then the dimensions are, so we add 10 centimeters to each dimension. Okay. So there are people here, I'm pretty sure that, is there a trial and error or a faster shortcut? Honestly, it really depends on how strong your arithmetic is. So I don't really I do have some strategies, and during the break maybe I'll show you that really large number one to show you one of the strategies that I use. But there is no real, like, it just depends how quick you are with the numbers. That's all I can say about it. Let's practice the quadratic formula before we get to the break. So this is a quadratic form that's in standard form. And by the way, you can solve this one by factoring. And if you don't believe me, we actually did it earlier. It was question 7. This is question 7. But we're going to use the quadratic formula. And that's just to demonstrate to you that you don't need to know how to factor and still succeed, at least for these types of questions. So in this case, you can just tell me ABC. So ABC are the coefficients of the terms here in order. And once you know ABC, you can use the formula. And here's the formula. So you see that the formula is this one from, I don't know when you learned it, probably grade 10, depending on where you studied school. Okay. You don't have to memorize this formula in this course, because you have a open book essentially for your test. You can look at your notes, and also you have your technology. Like, you could, if you had to solve this question here, you could use anything. You could use PhotoMath, you could use an internet site, you can do it by hand. It's all good. I care about you getting the right answer and more about how to set up the question. So when I get the quadratic equation, the first thing that I do is so. I set up a template, just like that. I make a little template for myself, and I'm just going to put the template here because we might use it later today. So I'm just going to keep this on standby for later. I find it quite useful to have like that. And then it's easier for you to populate these brackets just by kind of matching it to your reference right here. So B is 17, B is 17, A is 2, there's an A down here, and then C is 21, like that. At this point, it's a matter of you just being patient and trying to get to simplified form for the square root. Try to simplify that square root. So we have here negative 17 plus or minus. The bottom is a 4. Did anybody simplify the square root already? Yeah, it's 11. So inside the square root, it was 121. Thank you, Graham. So you got that. And notice that 121, as pointed out by your classmate, is going to turn into an 11 when you take the square root. This is an important thing for you to know. Not in the big picture, but at least for factoring. If the item here in the square root, the 121, is a perfect square, and you get like 11 or a nice whole number, that means that you could have factored. I'm not saying you should have factored, I'm just saying you could have factored. So just keep that in mind. That's a very interesting conclusion that you should come to, but it's absolutely true. So now we have two cases. We have x equals something or x equals something. And those somethings come from the this form right here. So we have x equals that or that, and you just pick the plus or the minus sign. So in the first solution, you could put the plus sign, and in the second solution, you could put the minus sign. And at this point, you are pretty much done the question. So the first solution I get is negative 3 over 2, and the second solution is negative 7. And that's the solutions to this equation. If you go back to question 7, you're going to see the same answers. Remember I made a typo and I put a 7 or something on the bottom? So you look at question 7. Same answers. Negative 3 over 2 or negative 7. And again here, negative 3 over 2 or negative 7. So there you go. That's the quadratic equation. You most certainly will need to know how to use the quadratic equation for sure next week on your quiz and for sure on your test. You need to know how to do it. Now this one here, the numbers are nice, but what if they were decimals? Well, if they're decimals, just go slower. I don't have any examples today where we're going to use decimals. I'm focusing more on like setting up application questions rather than punching decimals on the calculator. But for that moment, I need to cover one thing in the discussion though that's probably more important than decimals, and that is that the quadratic equation, you should be able to identify if there are solutions even at all. So I want to direct your attention to question number 15. So here's question 15. Yeah, you can't take negative roots. That is, you're right on point, Graham. So if we go to this question here, A is 1, B is 1, and C is 1. And let's put together the equation. So let's put the ones in here. For those that are seeing what I'm about to do, you're going to realize I'm writing too much, and you could call me out on that, but it's okay. Writing a little bit extra is not a big deal, as long as you understand what's going to happen here. You got -1 on the top here, you got a 2 down here, and what do you got under the root? What's under here? -3. And as mentioned by your classmates there, you can't take the no real solution exists. No real solutions exist here, since you can't take the root of a negative, just say the square root. But that's the thing there. There's no solutions, and it brings up an important point. You should check the discriminant if there's 0 or 1 solution. Thank you, Jaden. Yes. So I'm mentioning here, you should check that the discriminant is non-negative. So, I mean, just make sure it's not negative. So that's what I'm saying here. I'm saying that it's greater than or equal to 0, because then if it's greater than or equal to 0, I can take the square root of it. If it's 0, I can take the square root of 0. It's 0. And if it's greater than 0, I can still take the square root. It's going to be some positive number, whether decimal or not. It's still a positive number, and it is something meaningful. So, whoops. The commentary on the discriminant is outlined on page 2 of the notes. I'm just going to scroll to page 2. It's right here. See? You can always check to see how many solutions there are by first calculating or evaluating the discriminant b squared minus 4ac. If it's negative, there are no solutions. If it's equal to 0, there are 1. And if it's positive, there are 2, just as Jaden mentioned in the chat. So there you go. So that's the quadratic equation, and I think now we are in a position where I feel comfortable to take a break. I feel that we've gotten to the objective. So we can resume class at 9, and if you like, you can most certainly stick around, and I can show you how I did that really big factoring question that took Adnan 1 minute. So I will go through that now. Yeah, or we can talk about other stuff. So I saw a few people in the chat talking about the square root video. Who saw my square root video on YouTube? I put it up last night. What'd you think? I saw you mention something earlier, Amir. That's why. Sweet, yeah. It's so funny how it's. I mean, if you're close to a square root, that's funny. If you're close to a square root, that's perfect. It'll work. But if it's a far away, it won't be as good. Wait till you see my next video. Done. Let's go back to that factoring question, that really dirty one there. Okay, so someone grab a calculator and help me out here. So what I'm going to do is a little bit weird. Instead of, like when you do these things, you're like, you got to multiply to, well, I can't even spell, sorry. Multiply to 86, 87. You got to add to 192. The mistake that you might make in this question, if you have a calculator, is this one here. Don't try to satisfy that one. Satisfy this one. This one's easy to do. Okay? Give me two numbers that add to 192. That was rhetorical. I'll just pick two, okay? 100 times 92. Now, what's 100 times 92? That's easy. That's 9200. Look at 9200. Compare it to 8687. It's a little bit high, isn't it? So what you want to do is move these numbers further apart. Let's do 110 times 82 because those numbers add up to 192 still. I'm just taking the two numbers and I'm pulling them apart on the number line. What do you get there? Can someone give me the multiplication? Is it better, Sean? Is it getting closer to our target? Our target is this. Is it getting better? Okay, let's do 120 times 72. Where are we at now? 8640. Oh, dude, we went too far. Let's dial it back a notch. 19 times 73. Do that one? I think it's right. Now, obviously, I'm trying to have a conversation with you guys and do the answer. But if I was on my own at my desk with a calculator, I could crush this question, and you can too. You can crush this thing in less than a minute without having to do any like factoring of numbers or like times tables. Because if you wanted me to tell you all the factors of 86, 87, I'm too lazy. That'll take me longer to solve the question. The amount of time to figure it all, to write down all the factors, to write down by hand all the factors of 86, 87 would probably take me like 20 minutes without a calculator. Too much pain. So hopefully that entertained you a little bit. I'm gonna go to the internet here, and I want to just draw the picture of the parabola in this question. I can draw it by hand, but I'd rather just use a program. So just bear with me for a minute while I go to Desmos. Okay, so what I'd like to do now is discuss with you how you would locate or calculate the vertex, the x-intercepts, and the y-intercept for any parabola. Because these are typically the three quantities or locations on the graph that are most interesting or useful for application questions. As you might remember, when you're doing calculations with parabolas, these are really the ones that you have to use a lot. So I'm going to do them in the order of what's easiest and what we've done already in class. So the first one is the y-intercept. For the y-intercept, you just set x equal to 0. You get y equals f of 0. If you're rusty with function notation, you'll have to catch up on it because you need it for the calculus part of the course. It is under grade 11 math. Anyway, you get, what do you get here? What does y equal? Thank you, Zan. So the y-intercept is 0, 12. The y-intercept you could really figure out by just looking at the equation and making the x's disappear because x's are 0, so you're done with that one. So that's how you get the y-intercept. For the x-intercepts, you set y equal to 0. So that's what we were practicing in the first hour today. If you set y equal to 0, you get x squared minus 7x plus 12 equals 0. I'm going to use factoring here because it factors and you get x equals 3, sorry, negative 3 and negative 4. So you get x equals 3 or 4. So the two solutions are 3, 0. I could put and there, it's fine. But I'm just going to put or because I don't want to confuse anybody with the logic of the solution method earlier. So let's take a look at what we just did here. This is more or less a review of the first hour. So here's the y-intercept. See? Boom, right there. Nice big point there, okay? And the x-intercepts, let's do them in pink. So there's one over here, and there's one over there. So that's these guys. So the one that I haven't indicated yet is this guy here. So that's the vertex. So what we're going to do now is calculate the vertex. This is the new thing, the thing that I haven't discussed with you today. So there are different ways of finding the vertex. How to find the vertex. I know 3 ways. First way is you can complete the square. Second way is you can average. And then the third way is you can use a formula shortcut. I'm going to talk about the formula shortcut, which is h equals negative b over 2a. I should mention here that the vertex is h comma k. So I'm going to use this approach. The reason I like this last one is because what if you don't have the x-intercepts? I realize that we have the x-intercepts here, but what if you didn't? Then you have to go and find the x-intercepts to do this. It seems kind of backward to do 2 things when you only need 1 thing. So I'll calculate the vertex right here. So h equals negative b over 2a. So in this case, b is, if you go back to the question, a is 1, b is negative 7, and c is 12. So a is 1, b is negative 7, and we don't really need c here. So if you clean that up, you get 3.5, which is exactly what you see here. You get 3.5 on the graph. And then how do you get k? You get k by putting it into the original equation. So you plug in 3.5 into the original equation. And that's the procedure for finding the vertex. So once you clean that up, you get negative 0.25 or negative 1/4. So those are the 3 kind of the 3 cornerstones of parabolas. Can you locate the vertex? Can you locate the x-intercepts? And can you locate the y-intercept? And once you do those 3 things, you are all good. Thank you, Sean. I try to do it this one. It's hard, like it's hard because this thing that I just showed you on your screen here, imagine that I had a magic wand, okay? Imagine I had a magic wand, and this single slide on the screen, I went and I could go to any kid in grade 10 and tap them in the head, and say now you're an expert, because this thing here would be basically 1/5 of grade 10 math if you can do this stuff. So it's kind of sad that it's not done more compact to just tell these kids that it's just that's all it is. If you know any kid that's in grade 10, or if you have any friends like that have kids or whatever, I don't care about my notes. I don't share them, whatever. But like, take this page here, and it literally is a one-stop study sheet for grade 10 for quadratics. It doesn't have the quadratic formula, albeit, but hey. So if you had to use the quadratic formula, this thing over here would be a very annoying thing to do. Like, you'd have to use the big formula that we talked about. Awesome, Matthew. I'm glad. Awesome. Yeah, and you know what? If your brother's in grade 10, Matthew, you might as well show him just tell him to watch all the factoring videos, because basically he just got like 2 hours of tutoring for free. Because that's basically what it is. Seriously. Okay, I want you guys to try question 17. You can try it as an exercise on your own. 17 is the same thing. It's just basically dissecting the parabola and locating all the key features of it. So now we are in a position where we can do some application questions. I think what I will do with you is I'm gonna skip questions 18 and 19, and I'm gonna do questions 20, 21, and 22. Or no, because I did 20, 21, and 22 with the other class, and I already have them like on file. But I want to do them again with you guys, because I feel that I could do a better job. So I'm gonna do 21 and 22 and number 20. Yeah. And then tomorrow's class I'll do 18 and 19. Okay. Here we go. We're gonna do 3 questions that go together. They're one package deal, and they will seem very disjoint to you. Like, you're like, why are they connected? It's like watching a movie where it doesn't make sense until the very end. So hopefully that's the case here as well. So here we go. If Bob takes 5 hours to paint the house and Mary takes 4 hours to paint the house, how long will it take for them to paint the house together? We're assuming the houses are all the same. Like, imagine like a development or something, and they're all the same. So sorry, I gotta close that door there. It's like someone doing construction outside. Anyway, I'm gonna ask you a math question before we do this, though. What does that equal, guys? What does that equal? Thank you, Graham. Why was that question easy to do? That's rhetorical. The reason it was easy to do is because time is on the bottom. And you are very well trained in understanding how to add things like these. These are called rates. A rate is something that has units on the top and the bottom with like a fraction. We've done many unit conversions, and those are all rates. In this case, the rate is dollars per hour. Now, this question here, 5 hours for $13, and then 7 hours for $9. That, if I asked you to add that together, you'd be like, that doesn't really make sense to me to add together. And on top of that, the pay rate's terrible here, so you would probably cry foul that I was not paying you well. Anyway, these don't make sense. These do not make sense, right? So I want to show you how the question that we're going to do here relates to that. Let's talk about Bob. Bob takes 5 hours per one house. And what about his friend there, Mary? How long is she doing this thing? She's taking 4 hours. I gotta do the fraction first because it's confusing. So you see how the issue is, it doesn't really make sense to add these together because you have hours on top. If hours were on the bottom, yeah, you could add them together because it would make sense. So why don't we do that? Why don't we take Bob there and say that Bob does the following. He does 1/5 of a house per hour. Of course, it's not cooperating with me. And Mary takes 1/4 of a house per hour. Does that make more sense to you now? I think it makes more sense because you have hours on the bottom and now they're combined rates. So if you want to start to see how they work together, you can do that. Together, you can just add them up. So that's 1/5 plus 1/4 house per hour. Okay, you know my grammar's off here. It should be houses or homes, but I don't think you're gonna get mad at me for that kind of stuff. Can we clean up this fraction for a second? Someone do the fraction, please. Is it 9/20? Okay, I'm gonna pause there. How do you guys feel about this question? Do you feel that this what I've presented here is fairly natural to do? Like the houses per hour, their productivity, I'm just adding it together? Does that kind of make sense? Awesome. 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 Can I hear from some more people? Because I'm seeing a lot of, I got 30 students, and thank you, Kyle. Thanks for popping in. Yes, I appreciate that. Just want to make sure that everybody's on point here. Because, there we go. Whoa. This the flooding of comments. Thank you, people. Thank you, Noah. Okay, so we don't want houses per hour, so we're just going to take the reciprocal to get the answer. So the reciprocal would be 20/9 hours. Let's put H here per house. There it is. Now you can take 20/9 and do some fun stuff here. So 20/9 hours is 2.2 forever hours. Or I did it earlier on my calculator. I was kind of messing around with this calculation because I was curious. It's 2 hours. Yeah, 2 hours, 13 minutes, 20 seconds. Okay, so we're starting to put together a little pattern here or a structure. So what I'm going to do now is I'm going to have some fun with you, and we're going to try to create a formula. Let's say that the time it takes Bob to paint the house is X, and Mary will be Y. Can we sort of create a formula? Instead of having numbers, let's put a formula. So Bob is X, Mary is Y. This thing is 1/x. This thing is 1/y. This is 1/x plus 1/y. I know that I went a little fast there, but let's take a step back and make sure that you're clear. The original times are x and y. We had to flip them, take the reciprocal, and then we added the reciprocals together. And then we went over here and we took that answer in its entirety and we flipped it. And that's the answer. So I'm going to call the answer Z. So how long is going to be Z? And there we go. So Z equals 1/x plus 1/y, all to the -1. So that's the formula But we can do better than that. We can make the formula look a little bit nicer than that. So I'm going to take you back into the depths of your memory from grade 10 science. Do you guys remember in grade 10 science talking about lenses? Who remembers lenses? Lenses and mirrors. Do you remember 1 over F equals 1 over DI and 1? Yeah, all of that stuff, Joshua. Concave, convex, magnet. Do you remember this equation? Who remembers that equation? Who remembers that equation from lenses and mirrors? Okay, Amir. Don't worry, because you got PTSD on that one, I see, Josh. But yeah, I wish you guys knew me back then because I could have sent you a workbook. I designed a workbook for this. Anyway, we're gonna talk about let's talk about electricity. So we're gonna talk about resistors in parallel. Who remembers electricity like resistors and batteries and things like that? You know when you have two resistors in parallel? Okay, good. So it's like R1 and R2. Okay, I haven't lost you yet. 1 over R total is 1 over R1 and 1 over R2. That's supposed to be an R. Okay, good. What do you notice about the structure of these equations? It's called inverse rate sum. See that? Look at that. Isn't that what this equation is here? It's just x, z, x, y. It's the same thing. Do you see how they're the same formula with different letters? Same structure? Okay. So that's the good news, guys, because Bob and Mary that we were talking about for 10 minutes earlier, Bob and Mary, their formula is exactly this thing here too. I want to show you how this thing here is the Bob and Mary formula for combined rates, if you want. It's also lenses and resist and other stuff, capacitors. There's other things that you would encounter in physics and other disciplines. So this question says solve for Z. Now, when I look at the equation, I'm like, probably some of you are like, hey buddy, isn't Z already by itself? But the answer is no, because the answer I want is Z equals question mark. I want Z. I don't want 1 over Z. So then you might be like, can I just flip everybody? Can I just flip this one and flip that? No, you can't just flip them. You need to combine them. You need to merge them into one fraction. So the way to merge them into one fraction is to get a common denominator. So this first one here, I'm going to multiply by y over y. And the second one, I'm going to multiply by x over x. And when you do that, you get the following. Oh, it's just a little slow there. You get x plus y over xy. And then if you want z, you just flip that. So z equals xy over x plus y. That's the answer. If you go back to the Bob and Mary formula, which was over here, if you go back to the Bob and Mary formula, sorry guys, I'm waiting for my screenshot to appear on the desktop. It's a little high speed. Where'd it go? There we go. Remember that thing? It's the same answer. This thing here is the same. It's just that this one's prettier. That one's prettier on the right. Let's just apply it to Bob and Mary quickly to show you that it works, okay? Bob, x equals, was it 4? Mary, y equals 5. Combined time is z Z equals, we have 4 times 5 over 4 plus 5. 4 times 5 over 4 plus 5 is 20 over 9. There you go. 20 over 9. You see how it's the answer we had earlier. So if that doesn't amaze you, I hope it does amaze you, but I think it's pretty awesome. I think that's pretty awesome. So we've connected this category of formula and this type of question here with Bob and Mary. This formula is very famous or very practical in an area of mathematics, and I should say in management, called operations research, or just operations. If you like this kind of stuff, I highly encourage you to look up the branch or discipline in management called operations research, and it'll be absolutely astounding to you the kind of questions that you can solve. So I'm gonna do something maybe at I want to make sure I cover the next example with you, but I'll just put that out to you. In this question, in the previous question, we had 2 people working on one task, but you could have 50 people working on 30 tasks. Can you imagine having a situation where you had a facility where you had 50 employees and you had 30 tasks? Well, isn't that what you do in construction management? That's what you guys do. You have your facility, you have all your employees there doing their thing, and then you have like a bunch of tasks. So I don't care, even if you're like, forget construction management, let's say you're just a contractor, right? Or let's say that you're you do home renovations, right? You got your crew of 5 people, and then on the site there's like 11 objectives during the day, and then they go there, and I'll just make up some names. Let's say that Johnny, me for example, he's terrible at drywall, but he's amazing at electrical. So you don't assign Johnny to the drywall, you put him on electrical. But then Mike over there, he's kind of good at both. And then you got Susie, who's amazing at drywall, but sucks at electrical. So you don't put her on the electrical, you put her on the drywall, and etc. You kind of like mix the people up, and you have to figure out how to assign them. That is an incredibly complicated math question. But there's obviously technology, and you can actually buy software from companies like IBM and otherwise, or you can hire consulting firms to figure out how to solve those types of questions. As a random footnote, when I finished my PhD, I had about a month before defending my thesis and writing it up and all that. So I had a month to kind of do nothing. And I mean, I could have gone to Cuba or whatever. I actually did after my thesis, but I spent a month because that fascinated me. So what I actually did was I actually sat down and I figured out the math, and I wrote my own software to do it. So anyway, if anybody after the quiz or whatever, I can show you maybe a sample of the output from the software. Anyway, it's not for a test because it's a super weird math question to solve, and many people have written like master's and PhD thesis topics on that. So let's do one more question today, guys. Remember, the quiz today is on the harder side. I'm not trying to destroy anybody, but your quiz today is a harder quiz, and some of you might not finish. Don't feel bad or get upset or whatever if you don't finish the quiz. If you run out of time, don't worry, because the quiz, whatever you've answered, it's saved, even if it kicks you out after 30 minutes. Again, just don't worry about like the actual mark or whatever. The class average is well over 90 for your quizzes, and all of you are doing pretty good on the quizzes individually. So yeah, it's gonna you might get a mark that's not that good on this quiz. You might get like a 70, but that doesn't mean that you're a 70 student. It's just I need to make the quiz hard so that I can 30 minutes. Same as last week's. You might not finish, but I need to make the quiz hard so that when I prepare the midterm for you, I find a healthy balance of how much to put. So I hope that you can appreciate that this is about me gauging the student body for that. I think it is 7 questions, Mason. But like I said, there is the potential. There are some really easy questions in there. Like, nobody's going to fail this quiz. Like, there's some easy questions in there. I'm just talking about, I need to see more of a spread in terms of the marks and the time to understand how to prepare the midterm for you. So that's where it's more me doing a little bit of research on you and on the process of the online testing. Okay, so one more question, guys. Then you can take a break, go get a coffee or whatever, and then do we have the backward option? What does that mean? Sorry, Amir, I don't understand. Oh, yes. Yes, on the quiz you can go back and forth. I'm pretty sure you can do that on all the quizzes, because when I demo the quizzes, that you can do that. Yes. If I'm certain that's the case. You just have to, at the top of the window, you need to have, you just press there's the arrows there to go left and right between the questions. Okay, so think of this formula for the question. Okay, so I don't want to use X, Y, and Z. I'm going to try to do something different. So let me just put this out in red or something and just really just shrink it out of the way, because I don't really care about that formula with those letters. So let's read the question here. 2 pipes together drain a wastewater holding tank in 6 hours. If used alone to empty the tank, one takes 2 hours longer than the other. Wait a second. One takes longer than the other, but when they work together, it's better. Does that not sound like Bob and Mary painting a house earlier? Isn't it just the same thing, just with worse information, but it's the same category of question? Because that's exactly what's going on here. So the first one's time alone, time to drain alone. Let's put here. The first one's time to drain alone is X. The second, up instead of 1, maybe tank. One takes 2 hours longer than the other, so it's X plus 2. Time to drain together is 6. Okay, so that's promising, because I think we have it now. I think we have it, people. It's just the same question. 1 over 6 equals 1 over X plus 1 over 2, X plus 2. That's the formula. That's the formula. And notice that this formula is similar to a category of question or algebra that I did for you in the first hour. Do you remember the one where we cleared the fraction? Because that's exactly what this question is, or can be solved by. It can be solved by clearing the fraction. Let's do that here. What could we multiply this equation by? Well, I don't want a 6. So I can multiply everybody by 6. And that would get rid of the 6 here. but I need to get rid of the x as well. So maybe I should multiply everybody by 6x. Now that gets rid of the x and the 6, but it doesn't get rid of the x plus 2. So maybe I should include x plus 2. And that is exactly what you multiply by. If you're like, can you do that in a more like efficient way? Sure. Multiply by everybody by the lowest common denominator. That's what you do here. See, the lowest common denominator is just the intersection, sorry, the union of all of these denominators. So if you put these denominators together and just kind of piece them together like Lego, boom, 6x plus 2, boom, that's what you put here all through. And now, that's all you got to do. You just got to clean that up. So let's take a look. This is probably the most satisfying moment of the solution, where you just get rid of all the fractions. Let's get rid of there, and here we'll get rid of the x, and here we'll get rid of x plus 2. Oh my goodness, look at that. All the fractions went away. Isn't that great? We have x plus 2 equals 6x plus 2 equals plus 6x. Apparently I can't talk and type at the same time, so maybe I should lower my standards. Okay, there we go. That's a typo. How do we solve such an equation for x? You want to make it equal to 0. Make sure you make it equal to 0, because that pretty much takes down this question. So you know ABC here. Can someone tell the class what ABC are? What's A? What's A? What's B? And what's C? Thank you. Tic-tac-toe, right? Tic-tac-toe. So 1, 1, sorry, minus 10. And you can clean that up. I'll ask for your help on this because I didn't get my calculator here. So can someone tell the class what is under the square root? Not the decimal, just clean this up here. Is it 148? Can someone come that it's 148? Thank you. Good. And if you clean that up further, there's two solutions. We're going to choose the positive one. X is approximately, I got 11.1 hours. Two? What's the 2? I don't follow. Oh, thank you. Well played, Adnan. Well played. So, let's go back to the question and just recycle a little bit here. So the first tank is going to be X, which is 11.1 hours. And the second tank will be 13.1 hours. And if you want to check it, we could check it totally right now. try this. This little check here. We'll do 1 over 11.1 plus 1 over 13.1 to negative 1. And you're going to approximately, you should approximately get 6. Hopefully you get 6. Can someone confirm that they got close to 6? Even give me 3 decimals on it. It's like maybe it's like 5.99 or whatever, or 6.0 something. Or I'll pull out the beast here, this calculator. This is my beast right here. I didn't want to pull it out today here. Okay, thank you, Graham. It's pretty close. It won't be perfect. It will not be perfect, obviously, because you have done rounding, or I have done rounding. But at least you can appreciate. Whoops, let's not do that. Let's not do that. Let's tone it down a little bit. There we go. Maybe I'm getting too excited with my colors today. Little gray for you too. See that? Look at the color. Got a little color motif going on. Okay, so hopefully that you found the material that we covered today a little bit of a review and not too dangerous. For those that were rusty with their factoring, yeah, okay, it kind of sucks, but you'll get back up to it. I recommend that you watch the YouTube video on factoring, the 2 of them or 3 of them that are recommended. We have a bit of time, so maybe we'll go practice another quadratic equation now. And the 2 application questions that I did not cover with you, I will cover them in my class tomorrow, and I will post them as a separate video on YouTube. So that's pretty much it, guys. Let's dip back here if you want to do one of these other quadratics questions. I say we go through question 17. Okay, does anybody need this slide up still? Do you guys want this still on the screen? Okay. I will post this as you're writing your quiz today. I will post it on Blackboard. Let's go back to question 17 here. And we can just practice getting the X-intercept vertex. So, question 17, let's go for the Y-intercept. That would be y equals f of 0, because you make x equal to 0. So you get negative 5. You can factor this one. What are 2 numbers that multiply to negative 5 and add to negative 4? Thank you. Negative 5 and positive 1. So that gives us x equals 5 or negative 1. So what do we have now in our thing here? We have the y-intercept, which is 0, comma, negative 5. We also have our x-intercepts, which are 5, 0, and negative 1, 0. So the things that I'm highlighting are going to be the final answers, so stuff in blue. And now we need the vertex. So the shortcut for the vertex I mentioned earlier is this formula. You could also average the x-intercepts. That's negative b over 2a. So that equals 2. And then you get k by plugging in 2 into the original equation. Hopefully people are checking my numbers here and keeping me honest. Can someone confirm the vertex is the same? They agree? Anybody agree with my vertex? Thank you, Yazan. So those are the features of the graph. If you went and plotted this function on a grid, you would get a parabola. It would open up, and it would exhibit all of these characteristics. It would cross the y-axis here. It would cross the x-axis there, and the vertex would be that. I'm going to try to draw this with my stylus, and hopefully, if it's not too sluggish, I'll try to do it over here. If it doesn't draw well, forgive me. But 2, negative 9 is somewhere here for the vertex. The y-intercept is negative 5, so that's somewhere here. And the x-intercepts are negative 1 and 5. It shouldn't be bent like that, but hopefully you can appreciate the graph. So that's negative 1, 5, negative 9, and then this guy over here is the vertex. Whoops. So there is my 10-second sketch of the parabola.